This is Jason McIntosh with McIntosh Applied Engineering. In this video, I'm going to go through the coordinate mapper module. This is a relatively simple module used to obtain coordinate data from images. Usually the image will be an image from a graph, so you'll be taking the coordinates of the curve off of the graph, but it can also be used to find the mechanical coordinates of objects if you have a picture of them and you generally know its geometry. So I'm going to go through a few examples of how to use it. First, you need to go to the new module menu and create a coordinate mapper module. The controls show up here that allow you to establish a mapping between the screen coordinates and the image that you'll load in. And then there's a few options for manipulating the data. So I'm going to go ahead and load an image. I'm going to start with this response from a hats. Right now, as I move the cursor over this image, the image of the cursor is this doesn't work, a circle with a line through it. So what this is telling us is that we need to first establish the coordinate relationship between the image and the pixel locations on the screen. To do that, we're going to identify three locations on this image. The first one I usually use is in the lower left. The second one is usually in the lower right, and then the third one is the upper left. So I'm going to go ahead and type this coordinate in for point number 1. That has a x value of 20,000 for hertz in frequency. Oops, nope, it has a value of 20 hertz. Getting ahead of myself here. And the y value has a value of negative 20 dB. This coordinate is out at 20,000 hertz now. So I'm going to type 20,000 here. And the y value again is still negative 20 dB. And the third point up here now is back at 20 hertz. So I'll type in 20 for x. And the y value is 30 dB. Now, the x-axis here is on a logarithmic scale. So we're going to want to put a check mark on log x. And at this point, we can go ahead and click Establish Coordinates. When you do so, the cursor changes into a crosshair with the number 1. This is telling us that we want to click the crosshair on point number 1 up here, which is 20 hertz and negative 20 dB. That's down in this corner. So I'm going ahead and click there. Now it changed to 2, and so we're going to click on 20,000 hertz and minus 20 dB. And then it changed to 3, and so we're going to want to click on the third point, which is up in the upper left corner here. So now once we do that, as we move the cursor around in the lower left corner of the window, Aries is showing the coordinates of where the cursor is. And we can come along now and we can left click on this graph, and as we click, little X's will show up, and the data coordinate for those X locations are showing up on this graph here. So as I click along, I'm getting more and more data. Now, Aries has a feature that allows you to magnify this curve. If I put a check mark under Magnify Image, the image is increased by a factor of 4. To move the image around, you need to hold the Control key down, left click, and then drag the image along. And now we can see where we stopped with our data points here. Now you can come along and you can put in as many data points as you want, or you can just kind of hit the highlights. It all depends on how accurate you want this to be. But finding the coordinates is purely manual, and you can be as accurate or inaccurate as you like. I'm just going to run through here, be a little sloppy. Now I intentionally put this mark off the curve a little bit. If you want to go back and readjust the position, you can go over top of it. It becomes highlighted. Left click, and then you can drag that marker around. I can left click on this and drag that marker around. So you can get as as accurate as you care to. If you enter a coordinate out of sequence, so if I put one here, Aries is going to append this to the end of this coordinate list. So if I come back here, I'm getting closer to 20,000 hertz, 20,000 hertz, and then all of a sudden I'm just below 7,000 hertz. So now this data is out of sequence. You can press this reorder data in ascending X order button, and it will just reorder this data. And now if we go down, that 7,000 hertz got tucked in where it's supposed to be, and the last coordinate listed in this graph is over at over close to 20 kilohertz. So once you collect this data, you can copy it to the clipboard and paste it into whatever document or other program you have for doing further processing. Now, Aries has the ability to paste this data into the modeler graph element. So I'm going to go ahead and do that. I'm going to create a new module of the modeler, and I'm just going to create one element, which is a graph element. When this was created, this graph window got created. I'm going to kind of drag it in our view here a bit. There's nothing on it because it's not graphing anything yet. I'm going to go back here and I'm going to select advanced options from the graph control list of controls. And in this advanced options, I'm going to select the edit menu and I'm going to paste into the buffer from the clipboard, and I'll paste into buffer A. It's now asking me what kind of data are you pasting in, and the most common one is 2 columns, frequency and SPL. That's the first one that's selected, and so I'm going to go ahead and say OK. I'm going to hit OK here, and I'm going to put a check mark by the A buffer, which is where I put the data, and I'm going to come back to the graph. Apparently I missed A, maybe I put it in B. Yes, I apologize. I put the data into buffer B, and so this is the data that we got off of that graph. So that's an easy way of putting data into a graph, into a graph buffer. Notice that the advanced options here does have the ability to shift buffers up and down. So if I go to the graph advanced options, I can shift this up 60 dB or so. I'll hit apply, hit OK, go back to my graph, and now instead of it being around 0 dB, it's up around 60. So you can manipulate this data a little bit. I'm going to return to the coordinate mapper module though. I'm going to turn magnify image off. There's also an option to let you connect the points with lines. So now they're connected with lines, and the last point is connected to the first point with a dashed line. Aries will calculate the line length for you, and it'll calculate the area within those lines, assuming that you've created a simple polygon. Now, these line lengths and areas don't mean much for a frequency response graph, but it might mean something a little more important if you've got a piece of geometry that you're going to get data from. To show a little better how line length and area works, I'm going to create a new coordinate mapper module, and I'm going to load in just a simple graph here that goes from 0 to 10. Now 0, 0, 0, 10, these are already the default 0.1, 2, and 3 coordinates for establishing the mappings. So I'm just going to hit establish coordinates. I'll hit down here, click over here, and I'm not trying to be super accurate. And now I can come along and I can just, click on a box in here. So I'm going to go to this coordinate. It'll be 2, 3. I'll go up to 2, 5, over to 3, 5, down to 3, 3, and I'm going to go ahead and connect those with lines. And if I look at the line length here, it's saying the line length is 5 units, and that's roughly what we've got here. 2 units up, 2 units to the left, 2 units down, and it's saying it's 5.1, but if we were more careful with establishing the coordinates and where I actually clicked in here, we'd get something very close to 5. It's reporting the area as being just a little over 2, and that's accurate. We've encased roughly 2 of these unit squares, and so it's reporting an area of 2. So that's an example of how these can be used. I'm now going to create another module and load in an image of some geometry. Click Load Image, load in this image of this PC board. This was used for ultrasonic tracking, and the exact locations of these microphones were critical to get accurate ultrasonic tracking information. Now these were hand soldered in place, so their exact location is a little can be a little in question. Now I happen to know that the locations of these corners on this PC board, if this is 0, 0, this corner is 890 thousandths of an inch over to the left and 1,260 thousandths of an inch up. This corner is 2,000 thousandths of an inch over to the right, and it's at the same height as this corner here. Now, if the image was skewed, if it was rotated, Aries will take that into account. You don't need to have this image perfectly oriented up and down. You can have it slightly rotated, and that is indeed the case with this image. It is slightly rotated. Aries will correct for that when it establishes the mapping. So the first location here is 0, 0. The second one, I'll use this one, is over 2,000. So I'm going to change the X for that to 2,000 and Y will remain 0. This coordinate is 890 by 1,260. There's no log behavior here, so I'll go ahead and hit Establish Coordinates. I'll click on this corner, and this corner. So now we've got the coordinates established, and I can come along and I can click on these microphones. Now, if you look, the sensing element for these microphones is in the lower part of this screen. It's kind of being reflected by the flash from the camera that took this image. So I actually want to click on where the sensing element is, which is in the lower part of this screen. I'll click there, I'll click here, I'll click here, and I'll click up here. So now I've got the exact locations of those 4 microphones. If you've got a very dark image, these black X's don't work very well. You can tell Aries to draw them in white. They show up a little bit better on darker images, and you can then connect them with lines, and this will tell you the total line length and see if that's of interest for you. So that's the basic idea of using the coordinate mapper, getting data from graphs and getting coordinates from pictures of various mechanical geometries. If you have any questions, please feel free to contact us at May. I thank you for your time. I hope you found this of interest, and I'll wish you a good day.